Right, kia ora everybody, welcome to this how-to session today, and thanks for joining us. And welcome to everyone who's any new participants in the Aotearoa Property Data Network, and to any repeat customers, welcome as well. So today, as you will have seen on the registration, we've got a how-to session about using APIs from the LINZ data service, and it's going to be presented by James O'Brien here from our Open Data and Reuse team. Yeah, can we, I think just in terms of the running of the meeting today, can we just hold off questions until the end, and then there'll be time allowed for some Q&A at the back end of the session. Otherwise, I'll run through a karakia, and then we'll press in. Paia te mātauranga, kia marama, kia tupu, kia tiake ngā whenua, ngā moana, ngā arawai, kia whaitake ngā mahi katoa, araha atu, araha mai, tātou ia tātou, toi te kupu, toi te mana, toi tū te whenua, humie, huie, tai kie. And that's just to say that we pursue knowledge for understanding, developing and caring for the lands, bodies of water and waterways. We seek purpose in all that we do. Let us show respect for each other, hold fast to our language, hold fast to our spiritual strength, sustain the land, gather and go forward together. And with that, I will stop presenting and hand over to James.
Thanks, Ben. Hi, everyone. I'm James O'Brien. I'm in our Open Data and Reuse team. So the most common thing that we manage that people are aware of would be the LINZ data service. But we also have a lot of interaction internally, web mapping, data analysis, that sort of thing. So normally with these kind of demos, we've got quite a lot more time and usually face-to-face. So we're going to do things a little bit differently today. Instead of going through like the PowerPoint presentation and stuff, there's just not enough time. So we're just going to rip into a pseudo-live demo of some of the more common things we get asked about the API services that are provided through the LINZ data service. So bear with me if we're covering some stuff that you might already be super familiar with, and if it's anything that's either a little bit beyond you, we're always available for any questions through our inbox, and we'll provide contact details for that at the end, and probably when we send out the meeting recording. So yeah, I've also got my team is in the chat today, so I'll be leaning on them if we need any Q&A support. On that, if you could just hold any questions to the end, and we'll have about 10 minutes at the end to run through anything. We're also going to be diving, sort of skimming over the top of some of this stuff, and more like showing you some of the potential, but to really dive deep into it, it needs a bit of time and effort that we won't get through in 25 minutes. So yeah, we'll share my screen. We'll get into it. Screen, we want that one. Drag that back over there. Cool. And I'll turn my camera off so that the things speed up a little bit. So first of all, I'm going on the sort of the assumption that everyone's already familiar with the LINZ data service and the type of work that we do. But just briefly, it's a data portal. There's about 1,600 layers or so. I go to browse. It should tell me, okay, 2,700. Sorry, I'm off by 1,000. But 2,700 layers in there, and a lot of it's to do with the property data sets. So it's coming out of Land Online, our aerial imagery, our elevation models, hydrographic, topographic data, and the gazetteer, that sort of thing. So we're going to be sort of skimming over quite a few different layers today just to get a bit of a broad idea of it. But I thought we'd first kick off just with a basic overview of what you get out of the box when you're looking at API use. So Go to say the into property titles layer. So common one that very very high use. So you can see a little admin behind the screens thing here. It's quite a high use layer. It's also a high volume layer. There's a lot of content inside it. So on the Services and APIs tab, you can see there's 4 options here. So broadly, the WFS, if you're not familiar, this is effectively streaming data directly from our service into yours. Quite commonly, this is applications like QGIS. For this kind of web service, it's a little less common for AGOL. We'll get to that in a minute, or ArcGIS Online or ArcPro. There's REST services for that. It's kind of a different service. WFS change sets. This is, if you haven't come across them before, a way to keep downloaded data sets up to date without having to download the entirety of a data set. So this is, I think, 2.3 million objects in this data set. It gets updated at least once a week. You don't want to have to download 2.3 million features every week. So if you are managing it through a download service, change sets are absolutely for you. And again, we'll get to that in a bit more detail later. Spatial Query API. It's kind of like a little buffer zone you can output. And the CSW, this is, these two here are common across the vectors and the raster data sets. The CSW is catalog services, so effectively metadata for the whole site. And that's going to be common across the rasters as well. We're going to more or less ignore these two today. But if you want to know more about them, again, you can come talk to us afterwards. So yeah, we'll just quickly duck into the rasters as well, and then we'll come back here and take a look at how to use these sort of in practice. In here as well, you've also got this other sort of window here, which is showing you a quick view for all of the API keys that you currently have set up. For any of the work you do with APIs, you need an API key. It's kind of your little token that lets you access the service, and you can access them through here. So all the ones that I have set up are going to be listed in here. It's easy to create them. You just hit create. If you feel like 99% of the work you do, data access only is absolutely appropriate. And you just give it a name, hit add, you get a key, and then it's gone, which I'm going to delete so that you guys can't steal my API key. It hides them automatically, and if you're using the manual ones, you've got to save them once they open up because they'll never reveal them again once you've clicked on it, but you can, for the basic ones, expand them out. So that's just really quickly into the API stuff. So once you've set up an API key, it's going to automatically populate. You don't have to go and add these in at any point if you're taking it out of the UI. So it'll just give you a list here of all the ones that you've got, and it'll add it where it says API token. So if I just jump over to a raster layer, so if we're looking at the Wellington urban aerials, again, Spatial Query API and the catalog services, they're always there. It's a standard thing. The alternative to WFS, the Web Feature Service, is the Web Map Tile Service, WMTS. Now, these are kind of like a pre-rendered, sort of cached way to distribute data. It's substantially faster in terms of immediate access than downloading the data set. You just get sort of small subsets. I'm gesticulating also, my camera back on. You kind of get small subsets of the data as you're sort of zooming in and out, and it won't return more than you need at any given time, so you can be quite efficient with how it's being distributed. Every raster layer, so the aerial imagery, the elevation models, so the DEMs and the DSMs, have a WMTS feed attached. And if you have been around the block for a while, these took or superseded the web map services, the WMS services that we used to provide. So they're totally gone. You won't find them on the LINZ data service anymore. Yeah, so as a part of this, we've also got another application that was released a little while ago called Base Maps. And this here is kind of like a stitched together version of all the aerial imagery for national coverage into a single sort of backdrop base map. And it's very responsive as you zoom into areas. the rendering is incredibly fast. What it'll do is, if you notice the colors changing as you zoom in and out, it's going to pick whatever the best available data is at that scale at that time, and display it for you. So again, this is used, you can plug it into your system, and away you go. This sort of image screen here is kind of like a preview window. This is not downloadable in any way through the Basemaps website, but all the data that is on the Basemaps website you can get from the LINZ data service. So this Wellington data set is feeding into the Basemaps service. And again, we'll show how to hook that up and access that in through both ArcPro and QGIS in a little bit. So that's very broadly, that's the out-of-the-box services that you get. I guess we'll load them up, see what happens. So if I open up QGIS, so still quite a few people from councils here. So probably a mix of QGIS and ArcPro, and I'm not sure what most people here are using, so I'll try and show both. Start with ArcPro. This is the Basemaps service loaded in. To connect it up, it's pretty straightforward. You go to the Basemaps website. Down on the right here, you've got all the different options. I've grabbed the WMTS NZTM 2000 quad. Just hit it. It'll generate an API key for you automatically. This expires every 90 days. If you're needing something that's more permanent, you can contact us and we can give you a permanent API key, but we track the ones that aren't 90-day expiring. Just there's no sort of system throttling happening. If we go back to here, go to connections and go to server, WMTS server. You copy and paste that in there, you hit OK, and it'll show up. I've done this, I won't do it twice. It just shows up in your list. So that's it. That's as simple as it is to add the Basemaps in there, and then you don't have to worry about keeping your imagery up to date. This is kept up to date as we get new imagery coming in through the LINZ data service. It gets added into the service and plugged in. This can also be opened in ArcGIS Online if you're using online web maps, as an alternative to the many other Basemaps that are produced in there. So that's in ArcPro. In QGIS, it's more or less the same thing, different way to get there, but you go to add WMS or WMTS layer. And then I've got one already loaded in here, but if you were to go on there, just paste it in, give it a name, hit connect, grab one of these. Different flavors for different reasons. This is a little bit beyond me, but I've been told that this one's probably the more efficient for the use we're doing. You add it in, and I've just added it in twice, but so it's got a bit of transparency on it. There it is. So it loads in, and again, very fast, very responsive. So we'd usually recommend Basemaps for any kind of backdrop imagery rather than going through and manually adding all the ones from the LINZ data service, but there are a couple of drawbacks. Firstly, it's like everything is there. You're not filtering this. It's kind of complete. There are ways to do that, but it starts to get a little bit like under the hood. Like you're starting to get into the more programming side of things, and it's faster to sort of go and get your own ones from the LDS at that point. But again, for like 99% of the use cases, it doesn't matter if you've got the whole thing in there. The performance that you're going to get won't make a big difference. So yeah, so that's the sort of the Basemaps are coming from. With the individual WMTS coming from the LINZ data service, if I jump back to there for a minute, to get it, it's exactly the same. Once you've got an API in there, you can just sort of copy it to the clipboard, jump back into a service, layer, new, URL, And there you go. And we'll grab it in the 2193 series because that's what our project series is in. And it's now over. If I turn that one off, you can see you can load that in straight away as well. And if you're noticing, if you saw the performance difference before, the rendering in this, the first time round, it takes longer. It's just not as efficient. The base maps are specifically designed for this purpose, but it is still very, very quick. I don't think... Yeah, so you also can pull through the metadata in the information tab, and this will come through into Arc Pro as well. So it's very basically loading in WMTS, so sort of ripping through it. The other one is the vector version of this, WFS, Web Feature Service. So if I go to the NZ property titles, and I will show this one only in QGIS, and I'll do an alternative in Arc Pro. It's exactly the same process. We just select the API we want to use, save it, head over to here. And I've already actually connected it here, but again, you just copy and paste it in, give it a name, click on it, and hit add. Now, this is going to do something really interesting. It's not going to be highly performative. If I zoom out, so we try and get the entirety of the country, this is going to be shockingly slow. Why would I show that? Seems like a bad thing to do. We've got an alternative to this. The speed at which this is happening is because it's trying to load in millions and millions of records. And as you can see, it doesn't happen particularly fast. Now, you can wait, be patient, save it, export it, do it manually. That's fine. But it's kind of rare, I'd say, that most people would need the entire country titles data. Usually, let's say you're working for a council, you're in a specific area, you want to know what's in, Remuera or something. You're wanting to be able to sort of nail down a particular area. So a lot of the time you'll find that you'll default to downloading because it's easy to draw a box crop or separate it to the territorial agency that you're looking at. And that's fine, if that's how you want to manage it, and there's ways that you can keep that data up to date. But we'd use a thing called spatial filtering or attribute filtering on the WFS calls if you wanted to still stream that data in or to generate downloads or CSVs or whatever you want to do. And we'll go into that in a little bit. Just wanted to show you the, that you can plug it in on the smaller data sets if you're doing, say, it's going to reload again, we'll remove that. If you're doing this on, say, a small data set like territorial authorities, that's going to take a second to stream it and you're done. It's fine. It's nice and quick. But on the larger ones, it can become quite a bottleneck. If you're using something like Arc Pro, they use the REST services. So this is the same layer. And I will say that for the use in Arc Pro, this is quite efficient. Still taking time, but they will pop in a second. To add these in, sort of connect up to the, in this case, it's coming in through my catalog. You can add these as REST services, but this is just where I've pulled it from if you've got it locally. Yeah, it's just coming from this one here, which you can see the pathway there. I'm pointing to it, which isn't particularly helpful. You got your REST service item. No. It's not enjoying this loading. Anyway, you can see how it works. It's still massive, so not the greatest thing in the world, but it does load more efficiently as a REST service in Arc Pro. Now, with the web feature services, this won't load at all. If I try to connect this in from the LINZ data service into here, there's kind of inbuilt policy reasons, I guess, why Esri doesn't play nicely with the OGC operations there. It does have the functionality in there to add them in. It just, I've never made it work. So, yeah, you do kind of get a bit stuck with the WFS ones there, but it does load in REST services quite nicely. We don't have comprehensive REST services for Esri products. There's additional costs and overheads and everything with hosting open data on 2 separate platforms. But if you want any further questions on that, you just come and have a chat with us afterwards. Right, so How am I doing? Okay, so the yeah, where am I up to? Right, back to LDS. So those are the basics, the basic way to connect to data. You just sort of go in there, you copy the layer WFS or layer WMTS capabilities and copy and paste it into your chosen application, and it loads. But you can get a little bit more specific than that. So let's say, for example, you don't want all of a data set, or you're using download services, but you're exceeding the LDS download limit. So LDS has a 15 gigabyte download limit, for example. You can use APIs for things other than just streaming data. You're sort of not limited by it. You can kind of bypass the UI and LDS in quite a few ways, which can be quite handy, particularly in process automation. If you're keeping things concurrently up to date and you don't want to have to go in there every time and hit the download button. One of the big ones, if you're downloading a tile area, and I'll find, I think it's the Taranaki EDM. Did I say this one? Yeah, that's right here. If I add this file to a map, and I get rid of this one, and let's zoom too. So it's quite a big area. This is quite a dense data set. We extend the crop out for the whole area. We go export it. All right, so it's almost 30 gigabytes. So it's double the minimum size, the maximum size requirements for exports on LDS. Your options here are basically to change the crop so that you're getting less data, make multiple downloads, and stitch it together, or pay for a courier service, which is never a thing you want to do on an open data platform. So you can use the APIs to sort of break this down into more manageable chunks. Now, all of the raster services that we release, they're broken down to tiles, quite small ones, but they're a regular grid. So if you know what your tile list is, you can set up the download to specifically crop 50 and 50, but also because they're always coming out in tiles, it doesn't actually matter if you have one download or 20, you're still getting 30,000 geotiffs coming out of it that you then got to manage. So you can break it up with exactly the same kind of data output. So to do so, you kind of need to build a query around your APIs. This is an example we've used. This is a platform called Postman. It lets you create post GET requests. But you can do this in Python, SQL, whatever your chosen platform is. But this is kind of a way we structured it. So you sort of connect up to the export URL, define the tiles that you want. In this case, we've just gone for 3. In the headers, it's got all of my my API key, which I won't expose here because it's one of the admin ones. The language you're doing it in this case, we're doing it in JSON. What this is going to do is send a request to the export service in LDS and bundle up data for download without you having to go through the utility. So hit send and give it a minute. All right, we get this little output. So what does this mean? It's just a rundown of everything that I just asked it to do. Most of it don't need to worry about too much. It's date stamps, just a bit of metadata about it. But if you go back to here, it's just created a download. So it's done that without me having to actually go into the export utility, which means you can set these up to run automatically. And if I hit download, it's going to get it as normal. What this won't do is automatically download it, but you can expose the download string if you want to also automate that. If I was to right click on this and copy the link address, and so there we go, paste it in here. This format is the same for every export that we do. LINZ services API and then exports, and then there's a little ID here. This ID is kind of like a job ID that you've generated, and this gets exposed in Postman when you generate that export. So if I go back into here, you can see the first thing is an ID. If I copy and paste that, head back into here, you can see that the 2 numbers match. So you can then grab this string, load it in through any browser, hit go, and it'll start a download. So you can run that whole process without touching the LINZ data service UI, which can be quite handy if you're handling large volumes or doing regular downloads of data for particularly rasters. With the vector data sets that we have, points, lines, polygons, the way we'd recommend doing that is through our change set service. So back to here, we go back to the property titles and into the services, there's this WFS change set. So a change set is a way of getting instructions on how to update data that you already have rather than downloading an entire fresh data set. So when you create a change set, it'll give you a list of all the history tabs. You select the range that you're interested in. Say that your data set was last downloaded on the 4th of August. Well, I want everything from the 4th of August to the 22nd of September, and you'll get some instructions on how to update your data set with these numbers involved. So it's a lot less than 2.3 million. So we won't go through that because it'll take a while to download and package up, but we can skip ahead to what it looks like on the output. So this is pgadmin. If I grab this here and hit go, this is the change set. So most of the data looks pretty similar to what you'd get in the actual table, but then you'll also have a table in here telling you what to do with it. So these will be update, delete, or insert. Update is changing an existing record, delete is getting rid of one, insert is a new record. And then you know, SQL, whatever you prefer to update data with, you apply the instructions. In this case, replace the ID here with the rest of the content. As a rule of thumb, don't ever open our data in Excel. You never know what's going to happen. As an example of why not, this is the Topo 50 contours change set. It's going to take a little bit longer, even though it's only returning 10. And the reason for that is the extreme geometry. This will break if you try to open this as an Excel spreadsheet. It exceeds the maximum capacity for the cell limits. So yeah, CSVs are fine, but into a database, basically, or directly into a GIS application. Inside a GIS, you can directly load these in as well. These layers here are all CSV files. They're not shape files or GeoPackages or anything else. So that's really quickly the change set service. We use change sets internally to keep data up to date that we provide to other staff for analytic purposes, and mainly that's the property data sets, so property titles, that sort of thing. We use Windows scheduled processes just to every week run a batch command that reruns the process, scans LDS, pulls down the data, and applies it. So again, if you're looking for more information on how to do that, please talk to us afterwards. So the other thing as well, we had a few questions at the Esri conference around spatial and attribute filtering. So I'll quickly go through that, and then I think we'll grab some questions. And sorry, I appreciate I'm just sprinting through this. This is normally quite a long presentation, but I'm just trying to keep up. So if I open up here, so these are kind of like, these are what GET requests look like. And this can be a bit gibberish if you don't know what you're looking for. But basically, you plug them into a URL, and they're going to return certain values based on what you've asked it to do. So in this case, I've got a few of these preloaded. Let's say we want to grab I've used some of the examples that have come from the documentation page that we've got. If you want to grab, pause over here so that I'm kind of hiding some of my code. Sorry, just find the page. UXML. There we go. All right. So this is operating on the roads dataset. Chuck it in here. up this, just copy and paste it, and I'll show you what it looks like before we actually explain it. Okay, so this is a GET request. So you are using a sort of a standard query language inside the URL string to export information about layers or the data service itself. And if you're not adding any additional commands into this, it's going to export it in kind of an XML format. So this is simply giving us a list of all of the field names in the roads dataset. So we've got the name, highway number, identifiers, lane numbers, status, and surface. So if you say you're doing work on, you want to know what's every road in the country that's a metalled surface, we can export data using these requests by filtering on these values, for example. And there's tons of ways you can do this. This is sort of one way of it, and I'll share a documentation page where we list all the different ways you can do this by box crop or radius around a point, that sort of thing. So if I jump over to QGIS, this is the same one. Example. I plug this in to here. So we connect to the LINZ data service. We put in an API key. We say what the service is. It's a WFS. It's got a version number. Gives it a request. In this case, we want to get the features, and then we add filters. So in this case, it's at, and we're going to go for the names of the layers. Sorry, this is the name of the layer. So it's a 50329. These are available in this data service. And then what the filters are. So in this case, we're looking for all surfaces that are metalled. And I want to output it as a CSV. You hit enter, and it'll just start a download. So the value of doing these, anything that's based in a string means you can plug it into code and have it sort of push into browsers and automatically download. I mean, we're doing it manually here, but you don't have to. That's kind of the key. And then once we've got it, you download it. Now I'm going to skip ahead the data extraction process and show you what that looks like coming out. I turn that on and zoom to the layer. Hopefully you'll spot a problem with the data pretty quickly. So this is exporting everything we just asked it to do. This is every metalled surface road in New Zealand. If you're eagle-eyed, you may notice that it's sideways. This is a thing called it's axis flipping. So depending on the software you're using, the different versions handle the coordinate transformations differently. So if I turn this on and zoom out, you'll see it's flipped the coordinates. So this other one is the same thing, but I've adjusted the version number basically, and I'll give you instructions on that. I point this out because if you follow the instructions directly from our website, it's going to flip it if you're using something like QGIS 3.x, whereas it might not do it if you're using another application. If it does, that's axis flipping. It's easy to correct. Just follow the instructions. So this is pulled in here. If I open up here, you can see no matter how I order the surface, it's only going to give me the metal surfaces. So for 221 metalled roads in New Zealand, which is a lot more than I would have thought. But there you go. Not everything's sealed. The other one you can do is, as we pointed out before, we tried to load in the titles table, and it loaded everything, and it took quite a long time. You don't have to do that. So similar to what we've done there, we've created a filter. We can filter on here we go, this one here. So it's the same thing. We're going to hit the data service, put in a API key, say it's WFS, what the surface is, version number, and that's 1 or 2 is going to that's what determines the axis flipping. Get the features, what's the layer name, and then filter. In this case, we're going to say we want the title number, and we want a specific title number. So I've gone and grabbed quite a large one, and I'm outputting it as a CSV. That could be a JSON or any other format you want, but in this case, I like CSV. And what that's going to do is output a single record. So that's the same data set, but we've gone and modified the WFS feed to be specific to one record, because all that data is still contained in there. So you can sort of get rid of it before it hits your service, and then the rendering is substantially faster. It just turns on and off. You can stack these up as well, give it a range. So in this case, I've grabbed Kapiti Island as well. So you can add them in. Again, quite a simple thing to do. If I go back to my query, the one below, you just give it a range, and I've grabbed 2 of them. So you can stack as many of these as you want, as will fit in the URL string, and URLs can have limited capacity. So it's not a excellent thing if you need like 2,000 of them, but if you've just got a few that you're interested in, you can quickly check on them. And these are quite handy, because if you're doing these commands quite frequently, you can kind of just keep it handy and just swap them in and out. Yeah, the other thing is, doesn't have to be CSV. So if I go back to here, this is exactly the same thing, just export it in the window. So I can go in and see information about it. This is everything to do with that particular layer, just in the browser. So if you're just after information really, really quickly, you don't actually need the spatial service. There it is, it's all exposed. It'll also give you the geometries. Again, example of why this doesn't play well in Excel. You don't want to open this. It'll break you. Scroll them down. And there's the second one. So they just got to go back to back. So all the information that you need about it. So this is the Kapiti Island one. So if you're on the LINZ data service and you hit the help button under LDS guides, the documentation is actually pretty good here. These are all under the web services and map tile services sections. But if you open them up, they'll give you examples on how to use this, the different ways they can be used, different applications that are commonly used in versions, that sort of thing. And that's the spatial filtering, attribute filtering we've just been doing. You do spatial filtering as well, just kind of running out of time. But that's based on geometry. So if you're trying to filter by, the Auckland area or something, kind of handy. Yeah, sorry, I will, Ben, your hand's up, sorry.
Hi, James. I was just going to throw to questions from there. Thank you very much for sprinting through all of that material. And I think we'll say, if anyone's particularly interested in particular aspects of that, more than happy to do follow-up sessions in greater depth. But yeah, while we've still, I'm just conscious of time. Do we have any pressing questions? Fire away. There's nothing come through the chat.
So we do have the LINZ data service at linz.gov.nz email address. So the stuff that, so I appreciate, I've just sort of gone tilt sprint through that. Just kind of usually like a 2-hour presentation. They've all come from fairly common questions that we've gotten from people in industry over the last couple of years. So if you do have similar questions around them, please let us know. We've pretty good at tackling them. The other thing as well is, if there's anything you want to know that we haven't sort of ripped through just then, please shout out. We're pretty responsive in our inbox, and happy to get on the phone and talk as well if you want to go something more in depth.
Yeah, fantastic. There's just a bit of feedback that's come through. Max says, just wanted to say that was a great overview of the LINZ APIs. It would have been super helpful a couple of months ago when I was integrating with LINZ. Apologies for the timing there, Max, but better late than never, I'd say. But yeah, if you do have any other questions with work that you're doing in future, as James has said, the team is really responsive and happy to help, and anyone else as well on the call. Yeah, thanks everyone for dialing in today. Thanks again to James for ripping through that at lightning speed, at about a quarter of the time you usually get. And yeah, if you do want to let us know if something in particular is of further interest, just sing out. We can set up deeper dive sessions. And yeah, otherwise, thanks again and have a great one. And we'll share the recording afterwards as well.
Thank you.